Hello guys, so this is a mini lesson on triangles. I know triangles have been tricky for a lot of people, so we're just going to go through really quickly today how to find the base, height, and area of a triangle. Now, the first thing you want to think about with a triangle, right, is how to find the base. That's going to be your first step. So let me draw a triangle really quickly. Okay, it's not a very good triangle, I apologize, but there it is, we have a triangle. Now, looking at this triangle, how do we identify the base? Now, as we've learned, the base can be any side length. So I'm going to start by choosing a side length that you probably wouldn't think of as the base first of all. Let's choose this one as our base. Now, I've seen some things on exit tickets like, well, this one's the base because it's the one on the bottom and the bottom is the base. That is a nice assumption, but as we've learned, any side length can be the base. So I can just choose this top side length as the base, and that's perfectly fine. What matters is that I choose the correct height that corresponds with this base. So we know that height has to go from the base to the very top of the triangle, and it has to be perpendicular to the base. So what top part, what corner of this triangle is the height going to reach to? So if we're starting here, we want to aim for the corner, the angle that is opposite the base. So we're going to be going to this angle right here. Our line, which represents height, should be perpendicular to the base. So let's sketch that in now. I'm going to mark a right angle here to show that I've created a line that is perpendicular to the base. All right, so now we've got our base and we've got our height. Excellent. Now, let's say this base is equal to 8 and this height is equal to 4. How would we calculate the area of the triangle? Now we know the area of the triangle formula is base times height, then divided by 2. So let's plug in our values. Base is 8 times height, that's 4, divided by 2. 8 times 4 is 32, divided by 2, that'll equal 16. So this is equal to our area for the triangle. Great, so we know that the area of this triangle is 16, but some of the questions that you guys will be getting on your homework, on your test, are going to ask you to find like a missing side length or a missing height. Now say they gave you the fact that, let me erase this stuff on the bottom so that we are not crowding up our board. But I'm just going to mark up here that we now know that area is 16. Now what if they told you that this was, let's see, what am I going to make it? This length was 6. Now they will ask a question, something like this. I'm going to put that 4 right there. If we know that the base over here is 8, the height is 4, and we know this side length is 6, they'll ask you something like this. What is this length right here? Now, the important thing to think to yourself is, what does this length represent? What does that even mean? Like, it's outside the triangle? Like, what is it doing there? How is it connected to this triangle? Well, remember, when we're measuring height of a triangle, it can be inside the triangle, it can be outside the triangle. All that matters is that it reaches from the base to the top at a perpendicular relation to the base. So we know that this is actually a height of the triangle. But wait, you may say, I thought 4 was the height of the triangle. Yes, 4 is also the height of the triangle, but only if the base is this side. When we choose this as the base, we need a new height that corresponds to the base as a perpendicular line which reaches to the new top of the triangle. So how do we find this missing height? Well, let's use our area of a triangle formula again, and let's plug it in. So we know that area equals base times height divided by 2. What's our base? 6. What's our height? It's unknown, so I'm going to put a question mark. And then divided by 2. And then that equals our area. Hold up, we do know our area now, right? Because we calculated it before and the triangle hasn't changed, so it's the same area. So we know this equals 16. Great. Now all we have to do is work backwards to figure out what this question mark is. Okay, so 6 times what divided by 2 equals 16? Let's get rid of this divided by 2 first. So now we have 6 times what equals, multiply 2 on both sides, 16 times 2 is 32. And now we're looking for 6 times what equals 32. Unfortunately, I haven't made this problem very neat for myself, so I'm going to do a little bit of long division over here. If I know 6 times some number equals 32, I know that I can get that number by dividing 32 by 6. So let's do that right here. 32 divided by 6, 5 here, 30, put a decimal point. You probably will not have to deal with decimal points on your exam when it comes to the sides of triangles, but we're just working with that for now. 20, 30, 18. So I'm going to be getting a answer which just has repeating 3's. So I'm going to round that to 5.3. So I know that my missing value, my height, is 5.33333 forever and ever. That bar represents that it's a repeating decimal. It will just go on infinitely. Okay, there is one last set of height and base for this triangle. What is the one side length we have not used yet? This one right here. Okay, so say, I'm going to erase this stuff now so we can get it out of the way. We've found that this is 5.3333333. We did all this stuff. Okay, let's label the last base and height. If this is our base, where is the height? Well, this is like Dora the Explorer. I'm just like waiting for you to answer the video. I'm going to have to draw a perpendicular line which reaches from my base to the top. Okay, let's start drawing perpendicular over here. So this kind of looks like a right angle, but it's not. So what I'm going to do is draw my line all the way until it reaches where the point is. Now it doesn't have to actually touch the point of the triangle. It just has to get to the same like height of it. So we have a right angle here. So we know that this base corresponds with this height. Now I could find, you know, the length of that and then calculate the length of the height based on my area. I can do that quite easily now that I know how to do that. Okay, let's do one more practice triangle. On this last one, we're just going to practice identifying the different pairs of base and height. All right. So if I had a triangle, I'm going to do a pretty normal triangle. Let's go with a nice right triangle. I think that'll be simple for you guys just to see. Okay, if I have this right triangle and I say this is the base, what's the corresponding height? Well, the line that is perpendicular to the base and reaches to the top. On a right triangle, this does happen to be a side length. This would be height. Okay, great. But what if I made this the base? Now where's my height? Well, the line that is perpendicular to the base and reaches to the furthest away point. So that's going to be this line. You see it extends from this base at a perpendicular angle all the way to that point, which is furthest away from the base. Now, if I chose the last remaining side as my base, where would the height be? This is the hard one because there is no line written on this triangle yet which shows you the height. So let's draw one in. We need it to be perpendicular and we need it to reach the point of the triangle which is opposite this base. which point of the triangle is opposite this base? Well, it's not this one because that's connected to the base, and it's not this one either because that's also connected to the base. So it must be this one. As you can see, this angle is like the furthest away from that base. This is the one that's opposite the base. So we're going to draw a perpendicular line from our base to that angle. And you see I've marked it perpendicular. So that would be our height. Okay, one last triangle. I know this is getting quite long, so I don't want to hold you for any more time, but this is important to know. If we have a super obtuse triangle, let's practice finding all the base and height pairs. If this is the base, how do we get the height? Are we going to draw it like this? Well, no, that doesn't fit because it's not perpendicular, is it? No, not perpendicular. So let's get rid of that. We don't need any of that kind of nonsense. With obtuse triangles, you may have to draw your height outside of the triangle. So let's go from the point. As we see, this is the point that's opposite the base. Let's start from here. And we're going to draw a line that is perpendicular to the base. So we're going to extend our base out and then draw our height straight down from that tip to meet the baseline at a perpendicular angle. So now this is our height. I think this is going to be one of the most challenging things for you guys to notice. So remember, height does not have to be measured inside the triangle. It just has to be perpendicular to the base, which can be extended, and it has to be reaching the point that is opposite the base. All right, that's all I'm going to show you for now. Thanks for watching, and I will see you tomorrow.